completed my first security scan on one of my VLANs back in my home lab, and I received a notification that SSH was running with weak encryption algorithms. And the only suggested solution was to disable those algorithms. So I went down the rabbit hole of Google trying to figure out how to disable those options, and this is what I found. I installed the Greenbone Security Assistant to look for vulnerabilities, and here's one of the results I got on my server 002. It says something about weak key exchange, and it's because of this Diffie-Hellman Group 1, SHA-1. And the solution down here is to disable it. And also on that same server, I got one for weak encryption algorithms with SSH. And it wants me to disable these CBC algorithms. So I've worked with SSH in the past, and I know that I can see what algorithms are being issued by default. I do a sudo it's going to look at the config and give me some information on it. And of course I have to type the right password. So when I go up and look at my SSH config for these KEX algorithms, I don't see the Diffie-Hellman Group SHA-1 listed here. So I had to go and find out why SSH is showing one thing and the system itself is showing something different. Now, to actually go out and test, I'm going to use Nmap, which has an option to look at my SSH port on port 22, and it's going to run a script that's going to come back and show me all the algorithms that are listed, that are running. So what it's reporting under the KEX algorithms, it's showing Diffie-Hellman Group 1, and under the encryption algorithms, it's showing those CBC. So the system itself is showing me one thing, and SSH is showing me something different. What I found was that Redhat and all of its clones, almalinux and rockylinux, run something called system-wide crypto policies. What that means is they have system policies that affect any program running on the computer that needs to use any type of encryption policy. The system-wide encryption policy overrides any policy set by the application. This appears to be in Red Hat 8 and also Red Hat 7. So you have the system policy that's available, and you can look at that policy by running this command, the update crypto policies -show. I'll copy that, go back over. If I run that command, it shows me that I am running the default policy. I've got another link here that shows all the different policies that are available: the default, the legacy, the future, and the FIPS. I don't recommend you change the system policy, especially if you're not physically at the location, because you could lock yourself out of the SSH connection depending on what your client is connecting with. So what I want to do is I want to look at this default policy that's here. And to do that, you would get on the machine. Let's see where we are. You would go to user share, crypto policies, and I'm down 1, 2, 4. I'll come back up. User share, crypto policies. In that folder, there's another folder called policies. Looking at the default policy here, I can see under ciphers that it is allowing this CBC by default. And there's another CBC that's there. So the default system policy is allowing the CBCs. So I have two options. I can either tell OpenSSH not to use the default system policy, or I could tell the default system policy not to use those CBC algorithms. So let's look at first disabling. Let's look at first telling SSH not to use the default. And when we scroll down to section 4.6, it talks about opting out of the system-wide encrypted policies. And here's the section for SSH. It says to look in etc sysconfig sshd, and it says to uncomment the line that says crypto policy. Okay. And then after that, you can specify the ciphers and algorithms that you want to include or exclude. So I'm going to modify that file. Etc sysconfig. But when you look at the SSHD file in sysconfig, it says here for the system-wide crypto policy, if you don't want to use it, which means you want to opt out, you would uncomment the following line. Now that doesn't seem right to me at first, because I would think if this is commented out, then it's not using any policy. But what it means is if this line is commented out or it is not there, then SSH will use the default crypto policy. So what we want to do is we want to tell SSH not to use the crypto policy. So we're going to uncomment that line and leave it blanked. We're going to save that. and you would have to restart SSH for those changes to take effect. But before we restart SSH, remember before we saw that we had the Diffie-Hellman SHA-1 was enabled, and down below we're looking for the encryption. We had the CBC enabled. Okay, so what we're going to do is restart SSH. It's called SSHD. Then we're going to go back and test it again with Nmap. So now when we go back and look at it, under our encryption algorithms, we don't see the CBC there. And we don't see the SHA-1 there. That's a different one. That's group 14 SHA-1, which is different. So by disabling the system-wide default policy, we're using the settings that are in SSH. Now, if you're running some version of Linux that doesn't use the system policies, you could still look into your SSHD config file and you can modify it there. So if I do a SSHD-T again, what you can do on those systems is you can take these lines for the ciphers, for the Macs, and you can just paste them directly into your SSHD_config file. And if you look at the man page for the config file, we're looking for the cipher line again. If you specify the ciphers, you can tell it to go ahead and use all the defaults, but if you put a minus sign in front of it, you can tell it which ciphers you don't want to include. So I could put a minus, and then I could put all these CBC ciphers separated by commas. But it also tells you here that it will accept wildcards. So I could tell it to just not do any CBC cipher. And to do that, I would have to edit my SSHD_config. And I would add a ciphers line that says minus, and you don't want a space after that minus. And I'm using a wildcard here, a *-CBC. Use all the default ciphers, but exclude anything that ends with a *CBC. So that will work on your Debian or Ubuntu system that doesn't use a system policy. I don't know if Ubuntu uses system policies, but if you've got any other Linux system and you want to go in and modify the SSHD config file, this is what you would do. So you could either specify the ciphers one after the other separated by commas, or you could use a wildcard and the result will be the same. The other option for disabling the weak algorithms is to tell the default system policy not to include them so that you don't have to manage your SSHD config file. So we're going to take out the changes that we put in. We're going to go back to SSHD. We're going to put that comments back in front of the crypto policy. Do sudo. I'm going to take that line out. That was left over from something else before. And I'm going to restart SSHD. So now when I go back and I test SSHD again with Nmap, you can see the CBC is back again, and also the default DH group SHA-1 is back again. So back in our documentation over here, it talks about customizing the system-wide policy with a sub-policy. So we've got the default policy that we're using, and then we don't want to modify that policy, but we want to add on to it. And they give examples here. You have to create a file in this folder, this Etsy crypto policies modules. And they give an example here. And they warn that the policy modules that you create must use capital letters, and it must end with the extension .pmod. And they give some examples here, and we're going to use something similar to this, and we're going to disable those CBC ciphers. And what you have to do also is you have to change your default crypto policy. So you're going to change it to default, and it's going to look for this mycrypto1.pmod in that folder, and it'll look for any file that you specify after the colon. And they suggest that you reboot, but I'm not going to reboot. I'm just going to restart the services. So if I switch over to that folder, I've created two files, one to get rid of the SHA-1 and one to get rid of the CBC. And these are just text files. So if we look at the first one, there's a comment first, and there's that cipher line again. It says cipher equal minus star CBC. Now this, in the SSHD config file that we changed, it had ciphers with an S, but here it's just no S here, it's just cipher. And then if we look at the other file, it did not take that. I'll copy it again. For that one, we just told it we don't want to do any SHA-1 for the hash. So if we then look at our current crypto policy with the show option, we see that our default is the default, but we want to tell it to look in the modules directory, and we want to pull in the settings that we have for no CBC and for no DH. So the command is set, and then we say default, put a colon and then the name, and the name without the pbod extension, and we put a colon, and we do the other one. And again, it tells you to reboot your system, but I'm just testing right now, so I'm not going to reboot. When I go back and I look at my crypto policy, I can see it's default, no CBC. And I'm going to go back and run my test again. And you can see that the CBC is gone. And also the group 1 SHA-1 is gone. And that was because we modified the sub-policy for the system, but the result is the same. Now you have to make the decision if you want to make that modification to the system policy, and you have to remember to keep it updated. If you have some type of update, it may set it back to default. So it's up to you. You could either modify the default system policy, or you could go into the sshd_config. So that was very easy. 2 ways to disable the weak ciphers in OpenSSH on your Red Hat and clones like almalinux and Rocky. You have a default policy. You can either tell OpenSSH not to use that default policy, which will disable the weak ciphers by default, because OpenSSH has its own set of policies that it applies. Now, the system policy, if enabled, will override any policies you have set in OpenSSH. Thanks for watching. Go ahead and click that like button. I'll see you in the next video.